Welcome to chemistry class. Today I am going to discuss with you some basic concepts of chemistry part 5. First of all, stoichiometry calculations. What is meant by stoichiometry? The stoichion means that is element and metron means that is measure. Stoichion means element and metron means measure. So the stoichiometry involves the measurement of or the calculation of masses of reactants and products which are involved in a chemical reaction. So this stoichiometry calculation is fully based on balanced chemical equations. So if you're taking as an example 2H2 plus O2 gives 2H2, the simple equation. And according to this equation, we have 4 grams of hydrogen that react with 16 plus 16, that is 32 gram of oxygen forms 18 plus 18, that is 36 grams of water. So this gives a relationship between the masses. Then take as an example nitrogen when combined with hydrogen forms ammonia. So this is a chemical equation that expressing the formation of ammonia. And what is the purpose of this chemical equation? It is a short scientific way to express a chemical reaction. And this can provide many informations. First of all, consider the mass relationship. If you're taking the masses of nitrogen, there is 2 nitrogens, 14 plus 14, that is 28 gram of nitrogen. 28 gram of nitrogen that combines with 3 into H2, that means 6 hydrogens, totally 6 grams, which produces 17 plus 17, that is 34 grams of ammonia. So this gives the mass relationship, isn't it? And if you are taking the number of moles of reactants, here nitrogen, that is 1 and 2, that indicate 1 mole of nitrogen that combines with 3 moles of hydrogen, which produces 2NH3, that means 2 moles of ammonia. So this can provide the mole relationship. Then consider the volume relationship. We can take 1 mole that combines with 3 moles. So what is the ratio? 1 is to 3. So if we're taking 1 volume of nitrogen that require 3 volumes of hydrogen, which can produce 2 volumes of ammonia. So this gives the volume relationship also. And if it is molar volume at STP, this required 22.414 liters to occupy. That is 1 mole of nitrogen. Here we are taking 1 mole of nitrogen, so that require 22.414 liters at STP. So what about the hydrogen? It is 3 times of its volume. That is 3 times the volume of nitrogen. That is 3 into 22.414 liters of hydrogen at STP. And that can produce 2 volumes. That means 2 into 22.414 liters at STP. So this gives the molar relationship, molar volume relationship of reactants and products. And if it is 1 mole that consists 6.022 into 10 raised to 23 molecules of nitrogen. This consists this much molecules of nitrogen, and this can be taken as Na, number of Avogadro's constant. So what about the number of molecules of hydrogen? That is 3 times that of nitrogen, isn't it? So that is equivalent to 3 into Avogadro number of molecules of hydrogen. So that can produce 2 into Avogadro number of molecules of ammonia. So that gives the number of molecules. And this can relate the number of atoms also. If it is 1 mole of nitrogen, 1 molecule of nitrogen consists 2 atoms. So what is the total number of atoms in nitrogen? That is equivalent to 2 times of this one, that is 6.022 into 10 to the power 23 into 2, that much atoms. Similarly, we can provide the atoms, number of atoms So we can obtain the number of atoms also from the same chemical equation. So here many informations from the same chemical equation. The one is mass relationship, secondly mole relationship, then volume relationship is there, molar volume, molecules, number of atoms, etc. So this chemical equation is very useful to us for the calculations. So based on the balanced chemical equation, we can discuss a new term which is called limiting reagent. Then what is meant by limiting reagent? Here we have an equation. N2 when combines with 3H2 forms 2NH3. N2 combines with 3H2 which provide 2NH3. So we have the mass relationship, that is 28 gram of nitrogen combines with the 6 grams of hydrogen produces 34 grams of ammonia, isn't it? Then if there is a reaction mixture which consists 28 gram of nitrogen and 3 grams of hydrogen. The mass of hydrogen is only 3 grams. So here we have only 3 grams. So what will happen? If it is 3 gram, then it can react with only 14 grams of nitrogen and can produce half of the ammonia, that is 17 grams instead of 34. So who decide the amount of product formed? That is this hydrogen. The hydrogen is not sufficient to react with the 28 grams. That is only 3 grams of hydrogen. So this hydrogen that is completely consumed, this hydrogen is completely consumed. This is completely consumed during the reaction. And which limit the amount of product formed, and this is called the limiting reagent. So which is the limiting reagent in this case? That is hydrogen. So what is limiting reagent? Limiting reagent is a reagent which completely consumed during the reaction and which limit the amount of product formed. So see another case in which we're taking the second case, 28 gram of nitrogen which combines with the 10 gram of hydrogen. So a reaction mixture is given. This is the first case. See, this is the second case. In the second case, there is a reaction mixture which consists 28 gram of nitrogen and 10 gram of hydrogen. What will happen? We know that according to the balanced equation, the 28 gram of nitrogen requires 6 grams only. So here there is a 28 gram of nitrogen and there is excess quantity of hydrogen, that is 10 grams. So the 28 gram can react with only 6 grams. And what about the 4 grams? The 4 grams remain in the reaction mixture without reacting. So this amount is present in excess, 4 grams in excess. So this 28 gram react with the 6 grams of hydrogen and it produces 34 grams of ammonia. So here 4 grams of hydrogen is in excess. What about the nitrogen? That is completely consumed. This is completely consumed. So what about the nitrogen here? This nitrogen which limit the amount of product formed which is completely consumed. That is the limiting reagent. In both the cases, in the first case, hydrogen is the limiting reagent, and in the second case, nitrogen is the limiting reagent. So the limiting reagent that depends upon the amount of reactants. Okay. Then see as an example, a question. A mixture which contains 56 grams of nitrogen and 10 gram of hydrogen. Identify limiting reagent and calculate the mass of ammonia produced. So how will you find out how will you identify the limiting reagent? First of all, there is 56 gram of nitrogen that is given. So we have to write a corresponding balanced equation. In all stoichiometric calculations, first of all, we have to write a chemical equation. And we know that here nitrogen which combines with hydrogen, which produce ammonia. And you have to balance this equation. You know how to balance the equation. Here there is two nitrogens, here only one nitrogen, so multiply this with 2. Now there is 6 hydrogens, here only 2, so multiply this with 3. So this is the balanced equation. You add gas, 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 which indicate the physical state of the reactants and products. That is another information from the balanced equation. It provide which are the reactants and which are the products and their physical state also. And here we know that 28 gram of nitrogen combines with 6 grams. That means 28 gram requires 6 grams of hydrogen, isn't it? So you can write this 28 gram require 6 grams. So what about 1 gram of nitrogen? 1 gram of nitrogen require 6 by 28. So 56 grams require how much? That require 6 by 28 into 56. That means 28, 56. That is 2 times. So you can write this as, what is the answer? That is 12 grams. Here 56 grams require 12 grams. So what is given here? That is only 10 grams. So hydrogen is in less quantity and nitrogen is in excess quantity. So this hydrogen is completely consumed during the reaction, and the hydrogen is not enough to combine with the this is not enough to combine with the higher nitrogen, 56 grams of nitrogen. So here hydrogen is not enough, and this is completely consumed. So which is the limiting reagent? So hydrogen is therefore hydrogen is the limiting reagent. Therefore hydrogen is the limiting reagent. The amount of the amount of ammonia produced, that can be controlled by hydrogen, because hydrogen is the limiting reagent here. So from the balanced equation, it is clear that 6 grams can produce 34 grams of ammonia, and therefore 1 gram of hydrogen can produce 34 divided by 6 grams of ammonia. So therefore 10 grams, that is given, 10 grams of hydrogen is given, then 10 grams of hydrogen can produce how much grams? That is equivalent to 34 divided by 6 into 10. Once more, 6 grams can produce 34 grams of ammonia. Therefore, 1 gram of hydrogen can produce 34 divided by 6 grams. Therefore, 10 grams of hydrogen can produce 34 divided by 6 into 10, and this is equivalent to 56.66 grams of ammonia. So what is the limiting reagent? Once more, what is the limiting reagent? That is the reactant which is completely consumed during the reaction and which limit the amount of product formed. Here it is hydrogen. The next topic is related to solution. What is meant by solution? For example, if we are taking a little sugar and we are adding that into some water, sugar and water, which produces sugar solution. And what is sugar here? That is called the solute. And water which is present in excess quantities, that is called the solvent. And sugar and water produces sugar solution. Solute and solvent produces solution. If we are adding more and more solute, if we are increasing the amount of solute, if we are increasing the amount of solute, the concentration will increase. So the concentration of the solution that depends upon the amount of solute that is present in the solution. Okay, and there are different methods to express the concentrations of solutions. Here are the different methods. The first method, that is mass percentage, then volume percentage is there. Mass by volume percentage, parts per million, mole fraction, molarity and molality. After this, four are important. The one is mass percentage, then the second one is mole fraction, then the third one is molarity, and the fourth one is molality. So these four methods are involved in our syllabus. So we can discuss all these one by one. The first one is mass percentage. What is meant by mass percentage? That is mass of one of the component. Here it may be solute, mass of one of the component divided by total mass of the solution into 100. That is the method. And this mass percentage is commonly expressed in W bar W, that represent weight of the solute and weight of the solution. Okay. So in 100, that is out of 100. So what is mass percentage once more? That is mass of the solute or mass of any one of the component in solution divided by total mass of the solution into 100. Here's an example. What is the mass percentage of 500 gram of water containing 6.5 gram of potassium nitrate? How will you find out? Here there is 500 gram of water that is taken in a container, 500 grams of water which is taken in a container, and we are adding little potassium nitrate. How much grams? That's we are adding 6.50 grams of potassium nitrate into this and shaking it well, stirring it well. You will get a clear solution, isn't it? And what is the percentage? What is the mass percentage of potassium nitrate? We can find out the mass percentage of potassium nitrate by taking the mass of potassium nitrate that is given here, that is 6.5, divided by the total mass of the solution. What is the total mass of the solution? Here there is 500 grams of water, then plus we are adding potassium nitrate, that is 6.5 grams. So total mass is equivalent to 500 plus 6.5, then into 100. So what is the mass percentage? That is 6.5. That is the mass of potassium nitrate divided by total mass of the solution into 100, and the answer will be equivalent to 1.28 percentage. Okay, this is mass percentage. And next is volume percentage. Here instead of mass, volumes of one of the component and total volume of the solution is taken. Here the volume percentage is equivalent to volume of any one of the component divided by total volume of the solution into 100. So that is volume percentage. Then mass by volume percentage is there. That is the mass of the solute that is dissolved in 100 ml of the solution. So mass by volume percentage is mass of the solute that is dissolved in 100 ml of the solution. Then another important method is parts per million, and this is to express the components which is present in trace quantities, and here parts per million that is expressed in ppm, and which is the number of parts of the any one of the component out of million parts, and the mathematical expression is number of parts of the component, any one of the component, divided by total number of all components, total number of parts of all the components into 10 to the power 6. Here 10 to the power 6 means million. This is million. So out of the million parts, how much the number of parts of solute or any one of the component? That is the meaning. That is parts per million. And the next method to express the concentration of the solution, that is mole fraction. That is the fraction of the molecules. Suppose there is two components A and B. We can take two components A and B. The number of moles of A that can be expressed as Na, and the number of moles of B that can be expressed as Nb. Then if the total number of moles is equivalent to Na plus Nb, this is total number of moles, we can find out the mole fraction like this. The mole fraction of A can be represented as Xa, which is equivalent to the number of moles of A, that is Na, divided by total number of moles of all the components Na plus Nb. So this is the mole fraction of A. Similarly, we can find out the mole fraction of B also, and can be represented by Xb, which is equivalent to the number of moles of B divided by total. That is number of moles of B, that is Nb divided by total number of moles, which is equivalent to Na plus Nb. Here, this is the mole fraction of A and this is mole fraction of B. Here an example is given. Deepak puts 76 grams of sodium iodide in 500 grams of water. What is the mole fraction of this solution? How will you find out the mole fractions? Here 76.0 grams of sodium iodide. So we have to find out the number of moles. The number of moles N is equivalent to, here it is equivalent to mass divided by molar mass. Mass divided by molar mass. So first of all, we have to find out the number of moles of sodium iodide that can be taken as Na, and number of moles of water which can be taken as Nb, and number of moles of A can be obtained here as 0.507, and number of moles of water, that is Nb, can be taken as 27.8 by dividing the mass with its molar mass. Here the mass is equivalent to 76 and the molar mass of sodium iodide is 150. So dividing 76 with the 150, you will get the answer. So number of moles Na and Nb, this is Na, this is Na and this is Nb. So you can find out the mole fraction of A as 0.507 divided by 0.507 plus 27.8. So that is a method. Similarly, you can find out the mole fraction of B also, that is mole fraction of water, that can be obtained by dividing the number of moles of B, that is 27.8, divided by total number of moles. So this is the method to calculate the mole fraction. And the next one is molarity. What is meant by molarity? It is the number of moles of solute dissolved per liter of the solution. So for 1 liter, how much? In 1 liter, how many moles of solute is dissolved? The answer is molarity. Suppose here, what is the definition? Once more, the number of moles of solute divided by the volume of solution in liters. That is the answer. That is a mathematical expression. Here we have a table. If 1 mole is present in 1 liter of the solution, if it is 1 liter solution, what is the molarity? 1 mole in 1 liter. What is the equation for to calculate the molarity? Molarity M is equivalent to number of moles of solute divided by volume in liters. V in liters. So here 1 mole in 1 liter. So how will you find out the molarity? 1 divided by 1. So that is equivalent to 1 molar solution, isn't it? Then 2 moles in 1 liter. How will you find out? How will you find out? That is number of moles is equal to 2 divided by 1. So that is equivalent to 2 molar solution. And if it is 2 moles in 2 liters, how will you find out? 2 moles divided by 2 liters, 2 by 2. So that is again become 1 molar solution. And if 0.5 moles in 1 liter, what is the molarity? That is 0.5 m. So this m stands for molarity. Okay. So next term is molality. See the difference? Here it is molality. Remember molality. What is molality? It is the number of moles of solute that dissolved per kilogram of the solvent. It is the number of moles of solute dissolved per kilogram of the solvent. So how will you express the mathematical expression? How will you write the mathematical expression? The molality M is equivalent to number of moles N divided by mass in kilograms. So here this is mass of the solvent in kilograms. In last case, it is the volume of the solution in liters. Here it is mass of the solvent in kilograms. So we have a table here. If 1 mole of solute is added to 1 kilogram of a solvent, what is the molality? That is 1 molal solution. So here it is mole M that is used to express the molality. So 1 mole of solute is dissolved with 1 kilogram of the solvent, you will get 1 molal solution. If 2 moles mixed with 1 kilogram, so what is the number of moles in 1 kilogram? Yes, that is 2 moles. So what is the molality here? That is 2 molal solution. If 2 moles in 2 kilograms, 2 moles in 2 kilograms, that is molality M is equivalent to number of moles of solute divided by mass in kilograms and mass in kilograms. So this is equivalent to number of moles is equal to 2 for the third case, and the mass of the solvent in kilogram, that is 2. So 2 by 2, that become equal to 1 molar solution. And for the last one, 0.5 mole, that is dissolved in 1 kilogram of the solvent, and what is the molality? That is equivalent to 0.5 molar, isn't it? Then try some problems. The first problem, calculate the molarity of a solution prepared by adding 4 grams of sodium hydroxide in enough water to form 250 ml solution. How will you find out? So in order to find out the molarity, here we have to find out the molarity of the solution. Here it is molarity. So we know that molarity is equal to number of moles of solute divided by volume of the solution in liters. So first of all, we have to find out the number of moles of sodium hydroxide. How will you find out the number of moles of sodium hydroxide? The number of moles of sodium hydroxide is equal to mass of sodium hydroxide divided by molar mass. And mass is equivalent to 4 grams here. Molar mass is equivalent to sodium hydroxide. The molar mass can be obtained, that is equivalent to sum of the masses of all the atoms, that is equivalent to 23 plus 16 plus 1, and is equivalent to 40 grams. So 44 divided by 40, so that is equivalent to 0.1. So the number of moles of sodium hydroxide is 1. And what about the volume? Volume of the solution. V of solution, that is equivalent to 250 ml. But in order to find out the molarity, we have to convert this into liters. How will you convert this into liters? 1000 ml is equivalent to 1 liter. So what is 1 ml? 1 ml equal to 1 by 1000 liters. So 250 ml is equivalent to 250 divided by 1000 ml. So this is equivalent to 250 divided by 1000 ml, isn't it? 250 divided by 1000 ml, or that is equivalent to 0.25 liters. So here the number of moles is equivalent to 0.1 and the volume is equivalent to 0.25 liters. So how do you find out the molarity? The molarity is equivalent to, molarity M is equivalent to, that is equivalent to number of moles of solute divided by volume in liters. So that is equivalent to number of moles is equivalent to 0.1 divided by 0.25. Here 0 0.1 divided by 0.25, that is equivalent to 0.4. That is the molarity 0.4 m. So this is the answer. So once more, go through the answer. We have to find the number of moles first, then we have to convert the volume into liters, then number of moles divided by the volume in liters, that is equivalent to 0.1 divided by 0.25, which is equivalent to 0.4 molar. So that is the molarity. Then go through another question, that is calculate the molality of a solution that is prepared by dissolving 4 grams of sodium hydroxide in 500 grams of water. Again, we have to find out the number of moles of sodium hydroxide first. The number of moles of sodium hydroxide, that is equivalent to 4 divided by 40 molar mass. Mass divided by molar mass, that is equivalent to 0.1 again. And we have to find out the mass of solvent. Mass of solvent, that is equivalent to 500 grams, and you have to convert this into kilograms. Again, the method is you have to divide this 500 with the 1000, so that is equivalent to 0.5 kilograms. Okay, so how will you find out the molality? The molality is equivalent to number of moles of solute divided by mass of solvent in kilograms. So that is equivalent to n is equivalent to 0.5 here divided by 0.1 here divided by 0.5, that is a mass of the solvent in kilograms, and your answer will be is equivalent to 1 divided by 0.1 divided by 0.5, that is equivalent to 1 divided by 5, or the answer is equivalent to 0.2 m. So feel the difference between molarity and molality. So here is a question, how will you prepare 1 liter of 0.5 molar solution of sodium hydroxide? And how will you prepare 0.5 molar solution of sodium hydroxide? Then we can take the molarity here. So molarity of sodium hydroxide solution M is given here, that is equivalent to 0.5. We know that 1 mole of sodium hydroxide is equivalent to GMM, which is equivalent to 40 grams. So for sodium hydroxide it is 40 grams. Then if it is 0.5 moles, that is equivalent to, 1 mole is equivalent to 40 grams. So 0.5 mole is equivalent to, that is half of this 40 grams, that is equivalent to 20 grams. Then how will you prepare 1 liter solution? You have to take this 20 gram of sodium hydroxide. Then you add enough water. You add enough water to make 1 liter solution. Okay. How will you prepare the solution? You take 20 gram, that is equivalent to 0.5 mole of sodium hydroxide. Then you add enough water to make 1 liter solution. You take a container of 1 liter, you put the sodium hydroxide, take the weight and put it in into the container. Then add enough water to make 1 liter solution. Okay, that is the method. Then how will you prepare 0.5 molar solution of sodium hydroxide? Again here 0.5 molar. Again we are taking 0.5 molar means that contains 0.5 moles. 0.5 mole again it is equivalent to 20 gram. Already mentioned 0.5 mole means that is 20 gram. So how will you prepare 0.5 molar solution? The molality is related to kilogram of the solvent. So here we are taking 20 gram of sodium hydroxide and you add 1 kilogram water. Here it is, water is solvent. You take 1 kilogram of water and that make actually 1 kilogram means that is 1000 grams. So total mass is equivalent to 1000 Total mass is equal to 1000 plus 20, that is 1020 grams. Total mass of the solution is equivalent to 1020, including the sodium hydroxide. So here we have to take exactly 1 kilogram water, then add this water into 20 gram of sodium hydroxide. So you will get 0.5 molar solution of sodium hydroxide. Feel the difference? Okay. So there is some difference between molarity and molality. The molarity is that is the number of moles of solute that dissolve per liter of the solution, and molality is the number of moles of solute per kilogram of the solvent. So molality is not liter. What is meant by that? It is not related to liter, it is related to kilogram. Okay. Then lastly, temperature dependence. The molality is independent of temperature because the molality involves the mass measurements. Mass is independent of temperature, and molarity depends on temperature because the calculations involve volume. Volume may change with temperature. So molarity depends on temperature while molality is independent of temperature. So that is the end of this lesson. Okay, we can see again. Okay.